Hello, welcome to Zigmatech Learning Hub. I will be your instructor for physics. For this class, we are going to be taking our exercises from Examguide app. If you don't have the application already installed on your device, I will want you to download the app in order to follow along in this class. Examguide is a leading educational app that helps students prepare adequately for various exams like UTME, post-UTME, WAEC, JCE, KCPE, IJMB, JUPEB, KCPE, BECE, JSCE, NCEE, NECO, etc. You can download the app from www.examguide.com or Google Play Store. Please subscribe to our channel and turn on the notification bell and get updated on new videos. Are you ready for this class? Okay, let's get started. Welcome to physics class again. Today we are going to look at motion. By the end of this lesson, you should be able to define acceleration, velocity, uniform acceleration, uniform velocity, instantaneous acceleration, and instantaneous velocity. And then finally, you'll be able to solve questions relating to rectilinear motion. Now, when we talk about velocity, we are talking about a change in velocity of a body with respect to time. So if you look at this car, the car is moving, right? So velocity means change in velocity, change in displacement with respect to time. Now, the body is moving from one point to the other, changing in speed. You know, like to a layman is a speed. But really it is a displacement because there is a given direction as the car is moving from one point to the other. So as the car is moving, as you're watching, we now say that change in displacement with time is called velocity. That is the meaning of velocity. Simply put, that let's say x2 minus x1 all over t2 minus t1 is what velocity is all about. Because as the car is moving, from this point, let's say point 1 to another point, x2, there is a particular time that the car has spent. So that is exactly what velocity is all about. Now, but then when we talk about acceleration, we are talking about a change in velocity with time. So acceleration itself is given as change in velocity with time. That means whenever a body's velocity is changing, like the body here, this is a perfect example of what acceleration is. At every time, velocity is changing as the time is changing uniformly. When we go to uniform acceleration, we talk about it. But anytime that the velocity of a body is changing gradually, then we say that the body is accelerating. The body is not accelerating because of how fast it's moving. You know, those days, the way the name sounds, people say is how fast the body is moving. Not really. It is the fact that the speed or the velocity of the body is changing. Like the one you're watching on the screen, V1 before, and after some time it will go to V4. So the speed is changing. And then the body is accelerating, provided that the time is going to be considered. That is the meaning of velocity and acceleration. Now, let's talk about the one we call uniform velocity and uniform acceleration. What do we mean when we say that the body is uniformly accelerating, or the body is in a uniform velocity? I'm going to explain it also on the board, considering what you're watching there. Look at this point. This is the point 0, right? This is the 0 time. After 2 seconds, that means started from here, moved to this point. After 2 seconds, it covered 4 meters. That's the distance is 4 meters after the time of 2 seconds has elapsed. Then when it got to 8 meters after a time of 4 seconds has elapsed, it goes another 1 and continues that way. We said that the body is in uniform velocity. Why? Because look at this. From 0 to A is 4 meters, and it took times, that is 2 seconds to cover it. From point A to point B is another 4 meters, and it took 2 seconds to cover it. And from B to C is another 4 meters, and it took 2 seconds to cover it. And the same thing it does throughout the motion. Therefore, we say that the body is in a uniform motion because the rate of change of displacement with time is constant, no matter how small the time interval is. So at every point, the same distance is covered with the same time. At every point, the same distance is covered with the same time. We say that the body is in a uniform velocity. And the same thing happens in acceleration. If the body is covering a particular, the body is in a velocity, the body is moving. And then for every change in velocity, the same time is used to cover it. We say that the body is in a uniform acceleration. So we say that uniform acceleration is the rate of change of velocity with time when it is constant. When the rate of change of velocity with time is constant, we say that the body is accelerating. And that is exactly what happened in this video that you watched. Now look at this again. We are talking about non-uniform velocity and non-uniform acceleration. Now look at this. What are you noticing? What you notice is that the body moves from A to B in this direction. It changes direction. Whenever a direction is changed, what happened? The velocity has changed. Now, when it goes from C to D, it changed another direction. When it goes from D to E, it's another direction. Now look at what happened. Remember that the time can never be steady. If the speed or the velocity changes, the time will never be the same. So when the velocity is changing with the change in time at different positions, we say that the body is in a non-uniform velocity. All right? And when the body is in a non-uniform velocity, it's going to be a curve. It's either that the body is speeding up or the body is slowing down. Look at this. If you check the last class we had on the velocity time graph, you now realize that it's either the body moves this way or that the body is going to move this way. This is speeding up. This is speeding up with this curve. And at that point, if you can really master this, you now realize that this is going to be a quadratic function or a polynomial, because at this point, the rate of change of displacement is not constant. The same thing happens with acceleration. So the same thing happens with acceleration because the rate of change of velocity with time is also not constant. So it's changing, and acceleration can really take different shape and different curve. That is what we mean by uniform non-uniform velocity and non-uniform acceleration. And most of the things you do on physics in this level of O level or grade 12 and so on, what you usually do is the uniform accelerated motion. That's the majority of the things you do. But I'm going to lead you in this lesson from the uniformly accelerated motion to that non-uniform accelerated motion and their problems. Let's keep going. You'll see that. Now look at this. We are going to talk about this non-uniform velocity because the one you have been doing is the uniform velocity and uniform acceleration. But look at this. He said instantaneous velocity and acceleration. Look at what that means. He said if a body undergoes a displacement, look at this. If from this point 2, let's say we call it point A, let's say from point A, it gets to point B. And let's say this, okay, let me call this 2 and this is 1. And you know what happened? There must be a time, T1 and then T2. Now, this is how the body is moving. Now, the lesson is saying that if it undergoes a displacement, change in x, because from here to here is going to be change in x with change in time. All right? Now, what is instantaneous velocity. In a layman's understanding, when we talk about instantaneous velocity, we are talking about velocity at a particular time. As the body is moving from here, from point A to point B, we can say, what is the velocity at this point? Let's say at that point, I can say that at 2 seconds. So what velocity will it be at a given time? That is what we mean by instantaneous velocity. Mathematically, we use a limit function and calculus to solve such problem. So look at this now. Said the limit of this function changing s with respect to time, as the time is very close to 0, we call it instantaneous velocity. And then instantaneous acceleration is also acceleration of a body at a given time. Now I'm going to show you the calculation that explains what this is all about. Look at this question. And JAMB likes this question most of the time. You also see it in further maths, and mostly JAMB and further maths, not SSCE. Now let's look at it. Let's solve this. He said the equation of motion of a particle is given by this equation. The equation is given as s is equal to -6. Okay, -6 minus 5t squared plus t raised to the power 3. If you look at this, this is a polynomial. This is a cubic equation. Now I said where s is in meters and time is in seconds, calculate the displacement and acceleration when velocity is 0. Wow, when velocity is 0. How are we going to do this? Now remember, if you have watched the video on circular motion, there was a point we made. There was a point we made on that place. We said that change in distance over change in time is going to give you distance with change in time is going to give you speed. Now, change in displacement over change in time is going to give you velocity. That means the derivative, the s over the t, is going to give you velocity. That is just it. Slope. Maybe you can attend more of further maths class to understand what that means. So now the slope of displacement time graph is velocity. We are going to apply it on this problem. What we need to do is to derive this expression. We have to differentiate s with respect to time to find the problem of velocity. So I'm going to say the s dt is going to be, if I differentiate a constant is 0, and I'm differentiating this displacement or distance with respect to time, so that is going to be minus 10t. Remember that these 2 times the 5 is going to give you 10, and this 2 reduced by 1, so 2 minus 1, which is going to be 1. Then plus 3 will come down and multiply this place. Remember there is 1 here, so it's going to be 3 times 1, and then t, 3 minus 1. That is how you differentiate a function with respect to the other. So everything here now turns to be 3t squared. Remember, this is velocity now. Velocity is equal to minus 10t plus 3t squared. At this point, we now have to find the displacement and acceleration when velocity is 0. At this point, I'm going to call velocity to be 0. If velocity is 0, I'm going to have minus 10t plus 3t squared is equal to 0. So that's going to be 3t squared is going to be minus 10t. T is here and t is here. I'm going to divide both sides by t. Divide by t, divide by t. T will cancel t. This thing will cancel. Remember there are 2t here, and one of them is going to be cancelled. We have 3t is going to be 10. And the t is going to be 10 divided by 3 is going to be 3.3 seconds. So at velocity equal to 0, the time is 3.3 seconds. Now, the question said I should find the displacement when the velocity is 0. All right. Now, I have to go back to the equation. Look at the equation. Let me do it here. I have to go back here and substitute t as time. So I'm going to have displacement is equal to minus 6 minus 5 bracket 3.3 all squared plus 3.3 all raised to the power 3. So I'm going to use calculator. Whatever I get by simplifying this, I'm going to record it as my displacement when velocity is 0. When this velocity is 0. So I'm using my calculator. So when I multiply that by 5, so I'm going to have minus 6 minus 54.45 plus 3.3 all raised to the power 3. So I'm having 35.937, all right? So when I add everything, let me clean more off here. So S is going to be minus 60.45 plus 35.937. So S is going to be minus 24.51 meters, all right? So, and the displacement is negative. That means it's moving in the opposite direction, all right? Okay, now another question there said that we should find the acceleration when velocity is 0. Find acceleration when velocity is 0. All right, how then do you find acceleration from here? You also have to differentiate again. You are going to do double differentiation. So we are going to have the ds dt is going to be minus 10 plus 3t raised to the power 2. Now this is velocity. Now which is minus 10 plus, 10t plus 3t raised to the power 2. Now when I say dv dt is going to be acceleration, which is going to be minus 10 plus 6t. So this is acceleration now giving us minus 10 plus 6t. So this is velocity, this is acceleration, and this is displacement or distance. These are the three quantities we have now. Now they said that I should find the acceleration when velocity is 0. When velocity is 0, the time we got was that t is 3.3. So I'm going to find this acceleration at that time when velocity is 0. So I'm going to have acceleration is going to be minus 10 plus 6 times 3.3. A is going to be 6.3, that is 18 times 18. So we have, that is 19.8 minus 10. So we have acceleration as 9.8 meters per second square. So that is acceleration at time equal to, at velocity equal to 0. Now we also have another question. It said we should find the displacement and velocity when acceleration is 0. So the displacement and velocity when acceleration is 0. So at this point we said that acceleration is giving us minus 10 plus 6t square. If acceleration is 0, I'm going to call this place 0 equals to 10 minus 10 plus 6t square. So 6t square is going to be equal to 10. So so we have t square is going to be 6 over 10, and then the square root of that, which is going to be 3 over 5, square root of 3 over 5. Whatever you have this, you substitute it back into this equation and this equation to find the velocity and displacement when acceleration is 0. We use this time, substitute it at this point and this one. You have a value for distance, displacement, and also use this time, substitute at this one and this one, you're going to have the displacement. Let's move on because we have a uniformly accelerated motion which we are going to solve. Now, we have a question also on the board. Now, a body passes a point. This question now is not under non-uniform velocity and acceleration. This one is under uniformly accelerated motion. So this one is about uniform motion. The other one we did was non-uniform. Now they say a body passes a point with a velocity 25 meters per second and it starts to decrease. Okay, look at this. Let's assume this is the movement. This is point A and this is point B. Now a body passes a point, let's say point A, with a velocity. This place is 25 meters per second at that point. Then there is another point and it starts to decrease at 10 meters per second. So when it gets to this place, probably brake was applied and it started sloping down with an acceleration of 10 meters per second square. That is what happened, deceleration. Now I say, what distance does the body cover after it comes to rest? All right, let's assume that this place is where the body came to rest. I'm going to call it V0, or the final velocity. I'm going to call it VF, which is the final velocity. And the final velocity at that point is going to be 0 because that was the point when the body or the car has come to rest. Now, what distance does the body cover before it comes to rest? I think I'm going to have this. Remember, we have found an equation of motion when we are proving it, where we said that VF is equal to U square plus 2AS. All right? I'm looking for distance. Final velocity at this point, it's 0. But then I'm going to use I'm going to use this place as my F and this place as my 0. All right? So I'm going to use it in order for us to be able to lose it because it's about calculation. So I'm going to call this place 0. We have V squared is equal to 0 plus 2 times A times, I don't know the S. Now, V squared, final velocity is given as 25. So this is 25 squared, which is equal to 0 plus 2 times, acceleration is 10 times distance, which I don't know. So 25 squared is 625. 625 is equal to 20 S. Therefore, if you divide both sides by 20, S is going to be 625 divided by, which is 31.25 meters. That is the distance the body covered. Let's confirm the answer. 625 divided by 20, 31.25 meters. All right. That is the distance the body has covered before coming to rest. Now, number 2, he said, at what time does the body come to rest? At what time does the body come to rest? So what time did the body take to come to rest? I'm going to use another equation, which we also have made its derivative. I'm going to use this. This suits the question. Because at this point, we are considering the distance with respect to time. And the distance has already been given as 31.25. So I'm going to say 31.25 is equal to 0 plus 1 over 2 times 10t squared. I'm looking for the time. All right, remember that U is 0. That is why I'm calling this 0. So this divided by this is 5. So we say that 5t squared is equal to 31.25. That is what time does the body come to rest, at what time. So we say that t is equal to 31.25 divided by 5 is 6.25. T is taking the square root, 6.25, which is 2.5 seconds. That is the time that the body comes to rest. Okay? And thank you. We have come to the end of this lesson. But before we go, we are going to take a few exercises from Examguide app. Okay, we have come to the Examguide app. This is UTME, the JAMB own. We are going to look at a few of these questions. He said that a train with an initial velocity of 20 is subjected to a uniform deceleration of 2 meters per second. the time required to bring the train to a complete halt is. All right, this is a question related to the topic we have done now. So we are going to solve this question to see a train with an initial velocity. Initial velocity is 20 meters per second. That is my initial velocity. And then, so at the end, it went to halt. That means final velocity is going to be 0. And the acceleration is using is 2 meters per second. And they say we should find the time it takes to do that. And this is a question of deceleration, which is also acceleration. And in this case, we are going to say that acceleration is change in velocity with respect to time. Now, 1 is 0. So without the so-called consideration of the fact that it is a brake that was applied and it comes to rest, leave that out of this calculation. It's just about a concept. 2 is going to be my A, which is going to be this. And final velocity minus initial velocity is going to be 20 all over t. If I clear this fraction, I'm going to have that t is going to be 10 seconds. So it took 10 seconds for the body to come to halt, and the option there is B. And that is option B on this one. Let's look for more questions. Okay, let's look at this number 2 question. And okay, look at this. Whenever you see a quadratic equation, that means a velocity, a linear motion, where you have a quadratic equation, you know that that is actually a differentiation, and that is about a known uniform motion. Now, he said that a velocity v of a particle t, or in a time t, is given by this equation. He said find the instantaneous acceleration after 5 seconds. So the velocity is given as v is 10 plus 2t squared. So instantaneous velocity means the derivative of velocity with respect to time, and that is the v over the t. And everything of constant is 0. So we have 4t. That is 2 times 2 is 4, and 2 minus 1 is 1 on top here. So it's not necessary to write it. So I have this. And it said at a time 5 seconds. That means dv dt is acceleration, which is equal to 4 times 5. And the acceleration is 20 meters per second square. And which option? Okay, that is option A. Thank you for participating in today's class. You can practice more questions using the Examguide app. The app scores and gives a detailed explanation of all the questions at the end of your practice test. You can learn a particular topic of interest with different modes like study mode, mock mode, and practice mode. It also has other features that makes learning fun. It is a must-have for all serious students. Download from www.examguide.com if you don't have it yet. See you in the next class. Don't forget to subscribe to our channel, hit the notification bell, and share the video to people that will benefit from it. Bye.